So now in this video, we're going to light these LEDs, like this circuit. They're parallel right now. We're going to split them up among these. These are different value resistors. And so in any case, we have the power supply going to a switch, and then to the resistor, and then to an LED. Right now, 3 LEDs though. And they should be about the same brightness because they just came out of the same pack. But it looks like that one might actually be brighter for some reason, and this may be the dimmest. So I'm going to put the dimmest to the circuit, which it should be the brightest after we apply power. And the one that look like it may be the brightest, it also depends on how they're facing you and stuff, I'm going to put to the resistor where it should be the dimmest, right here. So that's the thing with resistors. They have a value, and a long lead the anodes going to the resistor, short lead the cathodes going to the negative rail. LEDs are a type of diode. They only conduct and light up in one direction. So there we go, right there. And so we have a 1 kilo ohm resistor right here and a 510 ohm resistor right there. And it does look brighter. It's not the way that it's facing the camera or anything. This is a 2200 ohm resistor, and it probably looks a little darker than that one, but it should definitely look darker than that one. I find these little switches, they operate better than the big one. As you can see, I kind of have to push it just right to get a connection. These little ones, they've been working pretty much flawlessly this entire time. So I like the little ones better than the big one. So now before we move along, first off I want to point out we're using 5 volts at the power supply. Right there I add a little bit more because you lose a little bit in the wires along the way there. But we will measure the power supply voltage, and so that is at the rail. We just go to any point to the negative rail, and then any point to the positive rail. These jumpers go right in there, and there you can see 5 volts. A spec higher, but it's 5 volts. Now we're going to measure resistance, and this is an auto ranging meter. I just have to, sorry about that, it was on voltage, then I put it on resistance. And so we can't measure it while there's power going through here, but we can measure the resistors while they're in circuit as long as no power is going through them and there's no other component for them to go to. So that's just a little less than 1 kilo ohm, and so pretty much spot on, 1000 ohms. This should be about 510, and there we go. Once I got a good connection, looks like about 505. So they're not perfect, but pretty close. So this should be about 2.2 kilo ohms right there, which is about 2.2 thousand ohms. And so now the resistance tells us the electrical property, how much current. So now with all the switches, I put the resistor to the switch and then the other side to the jumper going directly to the negative rail. So there's no LED to light up to let us current know it's flowing. We're going to grab the multimeter again and take that. So 1 kilo ohm resistor is telling you that you're going to get for every volt 1 milliamp of current through it, because you take the voltage divided by the resistance, 1000, and milliamps is 1/1000th. And so if you cut the resistance in half, 500, this is 510, so the numbers won't line up perfectly, but you can expect for each volt 2 milliamps, and a 2 kilo ohm resistor, this is 2.2, but still be close. You can expect half a milliamp per volt. And so we're using a 5 volt power supply. That'll be 5 milliamps there, and 2.5 for the 500 and a 10 ohm resistor, so slightly different. And then it's going to be, actually, sorry, that's 10 milliamps right there. The 2 kilo ohm resistor is going to be about the 2.5. So we can expect 5, 10, and 2.5 approximately. Because remember, they are not perfect, and they're also not rated for the exact value I got there, but pretty close. So I need to set the meter to milliamps. This particular multimeter, we can leave the red probe there. We measure everything except for high current with the red probe right here. And we got milliamps. So what I'm going to do is a little trick that I like. Usually you have to open the circuit. You have to have a space where there's no components, and you bridge that gap with the probes. We can just go to the switch because the switch is an open circuit unless you press it. And so as long as the switch is not being pressed, we'll get the current going through it, and it'll probably be off a little bit. There you can see that's because current was going through the switch. The current actually has to go through the meter to measure it. Now we'll go, that was the 1 kilo ohm at 5 volts, and so 5 milliamps. So this is half the resistance, it'll be twice the current, about 10 milliamps, right there. And it was 510 ohms, so it's a little bit lower than 10, plus it's not perfect. And then this switch, this is a 2.2 kilo ohms, so we'll just say 2 kilo ohms. It'll be about 2.5 milliamps, approximately. And there you can see it's a little bit lower because it's a tiny bit higher than 2000 ohms. But in any case, it's pretty close. So that's the basic property of resistors. The reason why I got rid of the LEDs is because they actually take away some of the voltage from the resistors. Series components split up the power supply voltage, and there's a set amount across forward bias diodes such as LEDs and other diodes. And so those numbers won't line up like that. We have to look at the power supply voltage minus the diode voltage. We'll look at that in an upcoming video. For now, we just saw when it comes to resistors, they set current based on the voltage across them and their resistance. So now, I'll show you some more videos and the subscribe button. Upcoming videos, we're going to look at the diode. 1 or 2 more videos coming up. We're going to look at the diode forward bias and reverse bias. So, hope I see you on those, and also if you see a video on the screen that you like, please click one of those. Thanks for watching. I'll see you in the next one.